Welcome to A1, example 4. What type of relationship? So we're looking to study the commonality between x and y. Does the set of ordered pairs x and y satisfy? How do you know? So, as we look at this time they don't give us an equation. They give us the table with numbers. And if we take the generalizations we made from examples 2 and 3, so if we learn that if the second differences are the same, then we know it's a quadratic. And if the third differences are the same, right, when we had this example here, where all of the third differences were the same, we were dealing with a cubic. So here, we take a look at the differences to help us decide what type of relationship we have. So, we do our subtraction of 5 minus 1, and we're left with 6. Here, the difference between these two numbers is 12. Here, the difference is 18, and here, the difference is 24. Right, subtracting 59 minus 35 equals 24. So the second differences are not the same. So we look to the third difference. (18 minus 12 is equal to 6. 12 minus 6 is also equal to 6. 24 minus 18 is 6. And so we see this common difference here. And so because we see that common difference, we know that it's a cubic. And it's a cubic because the third difference is constant. Therefore, it is cubic. Now, the last question of the example is a little bit tricky. It asks to find the equation, right? So the relationship, right, is a cubic. And so we want to find this cubic in this form of ax cubed plus bx squared plus cx plus d. So that the ordered pairs, right, those xy values on this up above or on the previous page here, so all of these values, the xy values here, are satisfied. So all the ordered pairs above are satisfied. And then it says, give evidence that your equation is correct. So, in example 3, we learn that the difference, the third difference, equals 6a. Well, in this example, the third difference was equal to 6. Therefore, a must equal 1. Since third differences of a cubic polynomial are equal to 6a, using the table above, 6a equals 6. So a equals 1. when x equals 0, a times 0 cubed plus b times 0 squared plus c times 0 plus d, y equals d. Oh. Y equals d at x equals 0. When we look at the table, when x is equal to 0, y is equal to 2. So we can substitute that 2 is equal to d, because when x is 0, y is equal to 2. Right? We get that from the table, using that information from the table, right? 2 equals d. So we have 2 of our values, and so now we need to find the last 2. So we need to find b and c. Substituting 1 and 1 and 2 and 6, so 2 more points from the table, into the equation, we get these 2 things. We get 2 new equations here. Right? We plugged in 1, and we plugged in 1 for y, and 2 and 6 in the other one. And so now we have 2 unknowns. We have b and c, but we have 2 equations to use. So 2 equations with 2 unknowns. We're going to use elimination, and we can get our answer.